There was a survey that I asked you to do yesterday on day 0. So we're going to go over that survey for a little bit and just talk about what it was and what it was meant to be. And then we'll take some notes on genetics day 1 in that document that you should have uploaded. And then we'll give you some time to start, and you should be able to finish homework number 1, which will be due tomorrow. So there should be enough time for every single one of you that are here today to finish that assignment and submit it back to Canvas for us. So our essential question, our EQ for today is, what is meiosis? So we have some new vocab words we're going to learn today. And what words do we use to describe how many chromosomes you find in body cells and sex cells? So I just want to remind you what a chromosome is, because you haven't been in biology for a while. A chromosome is a piece of DNA. So remember, DNA was the last unit we did before we said goodbye to you last time. So we are talking about DNA during this unit of genetics, and also Mr. Austin will be talking about DNA when we start talking about evolution. So DNA is not completely gone. As much as some of you might wish it was, it's still definitely a big part of biology. Hopefully after today, you can say this I can statement. I can determine the difference between a haploid and a diploid cell, and I know how many chromosomes are in each one. So that's our goal for today, is to get through these tasks. All right, so I'm going to share with you my iPad now. And you all should be opening up your document that you uploaded. Oops. I can share my screen. Just so you all know how to do this, I'm going to just go to Canvas quickly here. So all of us link today's page in our calendars. So you could click on the calendar, or you can click right into the class and go to modules here. And under modules, we are in quarter 4 genetics. So yesterday was day 0. You should have done the things on here yesterday, which was just uploading that document and then doing that survey. If you click on today, you'll see that document again. And then also here's where you're going to submit today's homework assignment. So when we go into today, here's the survey again. And then to upload this document, you click this download button here and send it over to Notability. Also in Notability, I had my students, I think everyone was tasked to make a new subject and call it genetics, so that you don't have to look for this document every time you open Notability. If you put it in genetics, then it will always be there for you. All right, so here it is. Oops, I forgot to change this to quarter 4. Sorry, I changed everything else, but I didn't change this to quarter 4. So when you go on this first page, you can click on the day it is, and it'll take you right to the warm-up for that day. We're starting with day 1, Tuesday, April 6th. So to get us started, you were asked to take a survey called My Future Baby, and it asked you if you were given the option to choose traits for your future baby with there being no risk whatsoever of it not working, would you choose these traits for your future child? So even without doing the survey right now, you could go through and click these for yourself. Like, would you want to choose the sex of your baby? Yes or no? Would you want to choose if your baby was left-handed or right-handed? How about its height? Eye color. And then we're getting to some traits that might be a little bit more controversial, like increasing IQ, making somebody more intelligent. Would you choose to make your baby more intelligent? Would you choose to make your baby more athletic? I was just picturing an athletic baby and it was making me giggle. Like, I don't think a baby can be more athletic, but maybe they start walking sooner than their peers. Would you choose to have your child not be overweight or obese? So taking away traits that might lead to that. Would you choose to make your baby physically attractive? So the last three are taking away genes that could lead to a neurological disorder like ALS. Would you choose to take away genes that could cause Tay-Sachs, which is a fatal genetic disorder? And would you choose to make sure your baby has the right number of chromosomes so they don't have 3 chromosomes instead of 2, which could lead to Down syndrome, depending on the number of chromosomes, what pair it is, or something called Pettau syndrome. All right, so I'm interested in these questions here. What traits did you feel comfortable choosing for your future child? So if you could put it in the chat, or if you're in a classroom right now, if you want to say them, but which ones, or you can write them down on your own sheet. But I'd like some participation from the chat. Which ones did you feel comfortable choosing? Eye color. What's a CAC? Yeah. You'd feel comfortable choosing all of those for your future child? Yeah. Somebody's saying the ones that take away diseases. Some people are saying none of them. Higher IQ. Paula wants to choose the height. All of the ones that would keep my kid, oh, awesome, you guys. Safer, disease prevention, height and athleticism. Lefty or righty, somebody wants to be able to choose that. I'm curious why you'd want to be able to choose left or right-handed. You wouldn't want to be a lefty in anything except for sports? Why would you want to be a lefty in sports? People aren't used to it. Ah, so being a lefty would maybe help you have a leg up in sports. You would make your baby 7'6".
Well, I definitely wouldn't. But I'm saying, like, if you wanted to make it where you could just be a professional athlete, just make him super tall and super athletic.
Yeah, so that definitely changing the height and athleticism and giving them an advantage to maybe earning a college scholarship or a pathway to the NBA or NFL, whatever it may be that you think would give your child a advantage. The ones that expand their opportunities do not limit any opportunities. Nice, Quentin, I like that answer. The ones that would fatal would not lead to disorders. Okay, so number 3 gets at a question that I always think is very interesting. How would you feel if only wealthy parents were able to choose traits like higher IQ or increased athletic ability, or only they were the only ones that could choose height or lefty? What would that do to society? if only wealthy people, only the very wealthiest people could choose these things because they could pay for them. Yeah, Zinnia, some social hierarchy going on. Society would plummet. I agree with you, Bryson. I would feel somewhat discouraged. All the rich kids would be perfect. It would create a bigger divide in society. Absolutely. I agree with that. Some people would think they're better than others. Yeah. It could, it could potentially create like almost like a class system where there's some people are in this one group and the others are in another group. Like it really has it's kind of scary when I think about it. It's like a dystopian world. The rich would get richer. Interesting. So thinking about how having a higher IQ or the ability to be more athletic could lead to the future of those children being more, being richer and not having opportunities for all. That would encourage me into becoming rich. Oh, well, maybe that would be, I don't know. I don't know if that'd be a good thing or a bad thing. Society wouldn't be the same. Absolutely not. So then the last question I have is there a place that you draw the line with parents choosing traits? So is there something on this list that you're like, that's taking it too far? Yeah, the IQ one is definitely one that is up for that one for me too. Just parents being able to choose anything about their child before its birth. Maybe that's where you draw the line. Yeah. Ooh, personality traits. Yeah, definitely. Anything past disease. Okay, so just so I have a student who's direct messaging me about like that you shouldn't be able to choose anything except for if it would cause disease in your child. So anything that would help them be healthier, but not change their outcome as far as intelligence or. By the way, who decides what's physically attractive? That question always gets me every year. Like, how do you choose what's physically attractive, right? We all think different things are attractive, but how much? Anything that gives them less opportunities than a normal charm sounds like a bad idea to me. Poor baby, it will be everything his parents want and nothing what he wants. Yes. I'd also be curious if parents could decide the sex of their child, what that would do. Like, would there be one that's more like common than others? Which one do you think it would be, Aiden? Somebody in my class thinks there'd be less females. I don't know. I know some people that wish they had a female. My brother has 3 daughters. He wishes he could have a male. And in fact, he told me if I could choose and have a son, I'd have another child. But knowing my luck, I'll have a 4th daughter. So no way. All right, awesome. Well, thank you so much for sharing in the chat. As my notes say here, choosing traits like this are not something that we can do yet. It sounds kind of like science fiction. There's a lot of ethical debates about choosing traits, even ones that do stop disease or not, because where do you draw the line? So today we're going to start our unit on genetics. This was meant to be a hook to get you excited about this unit. So today we're going to take a look at how you do get your traits from your parents, because that's how we get them. We don't get them from our parents getting to choose and pick and choose from a list of traits. We actually can only get what our parents have to give us. So we're going to look at how traits are inherited. So inherited means how they're passed on. So how this is going to work is I'm going to take notes, or I'm going to be writing notes here on my notes, and I want you to do the same. If you miss something, there's a recording being made of this lecture, and also we have a new thing in Notability here that we didn't have first quarter. I'm going to create a public link to my notes. I'll do this after today, and we'll share that in Canvas. And then what that is once you open that, you can save that link to my notes onto your home screen on your iPad. And so each day when I update my notes, you can then look at them. And if you missed something in the notes, you can fill them in, or you can just use my notes if that's easier for you. If you're someone that likes to just listen and not take notes. So I will be creating a public link after today that you can take a look at. So we'll probably, I'll make that today and share it with you. And then tomorrow we'll make sure you guys all know how to open it and use it. Okay, so here is our diagram, and we're gonna be going over some vocab words here. So these are the words we're gonna be adding to our diagram. Somatic cell, which is diploid. We're gonna be adding sex cell. Another word for that is gamete. So these are things like sperm and eggs, which are haploid. We're gonna be talking about a cell division called meiosis, fertilization, and another cell division called meiosis. So where do all of these vocab words fit into this diagram here? So we're going to start off by talking about our parents. Okay, so we got to start with our parents at the top. So we have a female parent and a male parent, and they are made up of cells. Okay, every living thing is made up of cells. And if we were to pluck, let's say pluck a skin cell off of one of our parents, we would call that skin cell a somatic cell. So a somatic cell are the cells of your body. So they're things like skin cells, brain cells, muscle cells. And I could keep listing different types of cells for the rest of class, but I'm not going to. You get it. We're made up of cells, and we call those cells our somatic cells. The prefix soma means body. So these are the cells of our body, our somatic cells. So if we were to pluck a skin cell off of one of our parents, we would, if we looked at it under a microscope, we would be able to see that it has 46 chromosomes in there. So we call this number 46 chromosomes in humans, we call that a diploid number. So our somatic cells are diploid. Now, math and science like each other a lot. So I'm going to use an algebraic equation to describe diploid. So we use 2n equals 45. When we're talking about diploid, di means 2. So 2n equals 46. And this is for humans. Okay, we're talking about, right now we're talking about humans here. I'm gonna write that on here just to make sure you guys know. This is a human parent, female and male, who have 46 chromosomes in their somatic cells. Yes, Caleb, you are getting to what n equals. You're doing some algebra. Quentin, we just used 2n. I don't know why. It just what biology does. It's not like it could be 2x, right? But it's just n for some reason. All right, so some of your cells in your body are destined to become egg and sperm. And so what happens to create those egg and sperm is those cells have to undergo a cell division called meiosis. Meiosis, not eurosis, meiosis. So meiosis creates sex cells. So meiosis is what's happening at these arrows here, is when diploid somatic cells divide. There's actually 2 divisions that happen. We're not going to get into all the details of meiosis, but there's 2 divisions, but it creates cells that have half of the number of chromosomes that were in your somatic cells. All right, so another name for sex cells is gametes. This is one of your vocab words here. So it's just another word for sperm and egg are called gametes. And another word for them is called germ cells, so sperm and egg have lots of different names. All of them are just talking about the same thing. All right, so what we create after meiosis is a cell that has half of the chromosomes as the diploid cell did. So we use the term haploid. So notice our diploid cells, our body cells have 46 chromosomes. In our eggs, females, there are 23 chromosomes. Males, in your sperm, there's 23 chromosomes. So you only give half of your DNA to your offspring, your future baby. So for those of you who like algebra, n equals 23. So all we did was we took this 2n equals 46, and to get n by itself, we divide by 2. We have whatever we do to one side of the equal sign, we have to do to the other. So we divide by 2, and we get n equals 23 for humans. All right, so the time has come now to make a baby. So when this time comes, sperm from the male parent and an egg from the female parent are going to come together in a process called fertilization. Fertilization. I bet you didn't think you were going to draw a sperm today when you woke up in biology class. But here we are, you're doing it. All right, and so what is created when one egg and one sperm come together? We're taking 23 chromosomes plus 23 chromosomes. When they meet and that process of fertilization occurs, we have a zygote, which is a single cell that has all 46 chromosomes in it. So our resulting zygote is diploid, which is good because this zygote is going to develop into a baby, even though it's one cell at the beginning. And it needs a full set of chromosomes to become a full baby, right? So essentially we took an N, one N plus one N and made two N, right? Okay, so this zygote off is only one cell. But one cell turns into two, two turns into four, four turns into eight, and so on. And eventually, over enough time, about 9 months, you end up having a full-grown baby. This is my baby here. He's going to be swaddled in blankets. So there's another type of division that creates more diploid cells. So it turns a diploid cell, one diploid cell into two diploid cells into four, and that process is called mitosis. So mitosis makes identical cells from one cell into two identical cells. Caleb, you're asking about twins. There's a couple different ways that twins get made. Sometimes this first cell, the first fertilized cell will split into two, and then each of those two eggs will end up developing into a separate baby. Sometimes there's more than one egg that's released by the mother, so there could be multiple eggs. Some months, females release more than one egg. Oh yeah, Mr. Monzon's on it. If the one fertilized egg splits into two and develops two separate babies, those are identical twins because they have the same 46 chromosomes. If there's two separate eggs and two, then they're not identical twins. That's how you get like a male and a female twins sometimes. All right, so below this diagram that should now be all noted up, there's a little reading here that if you, sometimes some people learn better from reading versus like looking at this picture that we just drew all over. That's what this is meant for. So I just described all those vocab words here. So if you are somebody that likes to read for information and learn and highlight and take notes on that, that's for you there. It just goes over what we just noted, put on our notes. Mitosis, this is cell division. Here, let's say cell division that creates two identical diploid cells. So I love mitosis. Anytime you get a cut or you're growing, like if you're getting taller, sometimes freshmen are in growth spurts and you're getting taller throughout the year, it's because of mitosis. So your body is making more cells that are identical to your original cells. If you ever get a cut or an injury and you're like, how did that skin grow back? It's because of mitosis. So mitosis just makes more diploid cells, more body cells, where meiosis makes sperm and egg. All right, so down here we have some vocab boxes, and mine are already filled in because I filled them in last hour. But I'm gonna have, what we're gonna do is I'm gonna have you guys fill these in for yourself by looking at some slides that I have. So I'm gonna stop sharing this, but you should keep yours on your, that page. And let me find my, okay. So there's a lot of vocab in this unit. So I want to explicitly go over the vocab. And I know we just kind of took some notes on it, but I want it in another place for you. So when you're studying and doing your homework, you have a good way to review. So meiosis. This is the cell division that results in 4 haploid gametes, sperm and eggs. Yes, there are 4. From 1 comes 4. That's not the most important thing for you to know. It's just that meiosis creates haploid. So they have a single, or sorry, half of the chromosomes, and the cells they make are gametes, sperm and egg. All right, so let me explain this visual representation here. So this is a very simplified picture of this because remember in human cells, there are 46 chromosomes. This is showing 2, a yellow chromosome and a blue chromosome. Before cells can divide, they have to replicate all their DNA. You guys remember from the DNA unit, we talked about DNA replication. So when chromosomes replicate, they go from looking like these 2 sticks to these 2 X's. So these are 2 chromosomes. These are 2 chromosomes. They're just replicated. So in the first cell division in meiosis, these 2 chromosomes split from each other. So one of these came from your mom and one came from your dad. So mom and dad's chromosomes leave each other. They split up. And then the second division, there's a second split of these identical strands of DNA. So that's what makes the haploid sperm or egg. So we went from diploid cells to haploid cells. So this 2n would equal 2 and n would equal 1, which I don't even know if there is an organism that only has 1 chromosome. I could be wrong. Maybe there is. All right, the next word is diploid. So di means 2. So again, diploid cells have pairs of chromosomes. And you find these in your somatic cells. The cells of your body. You don't have to add that you have one from mom and one from dad. You can if you want, but just know that that's why you have two of them. That's why you have pairs. Your mom gave you one of hers and your dad gave you one of his. My visual representation for this one is not fabulous, but I just was denoting that humans have 46 chromosomes in their diploid cells. Dogs have 78 chromosomes. So different organisms have different numbers of chromosomes in their somatic cells. Dogs happen to have 32 more than us. That's why they're so special. And this dog is really cute. I'm going to be honest, in my notes, I just drew a stick figure and wrote 2n equals 46, and then I did my best to draw a dog and wrote 2n equals 78. All right, next up is haploid. So I always remember hap means, I think of the word half, and that's how I remember haploid. So these are cells that are gametes, and they only have one of a chromosome pair. So you only want to give your baby one chromosome because your partner is going to give them the other one. So haploid cells only have one of a chromosome pair. So in this human over here, I think she would have 23 chromosomes in her eggs. Dogs, because they have 78 chromosomes, have 39 chromosomes in their sperm and eggs. All right, you guys are doing awesome. We have 2 more words. I'm going to skip the last one on this list. Before I go to gametes and somatic cells, I just want to show you a picture of somebody's chromosomes. So this is called a karyotype. It's an image of somebody's chromosomes, a human's chromosomes. So if we were to, let's say, pluck one of your skin cells off and take a look at your chromosomes, this is what they would look like if we put them all into pairs. So you have one chromosome from your mom and one from your dad for chromosome pair number 1, all the way through through pair number 23. Now, pair 23 is special. It's your sex chromosomes. It's the ones that determine your sex. So in this image here, we have an X and a Y. Does anyone know what sex has one X and one Y chromosome? Anyone? I can't see my chat. Yes, Sophie. So just having one Y makes you a male. So this person right here that has an X and a Y would be male. Females have 2 X's. So we'll talk more about X-linked traits and the importance of the X, but this is what a diploid picture of somebody's diploid cells would look like. Haploid would only have one of each of those chromosomes. All right, gametes, again, are sex cells. So egg or sperm. They are haploid. I feel like a broken record. Hopefully you're thinking I sound like a broken record. And your homework is going to be so easy. for this picture, I would draw sperm and egg. By the way, sperm are much smaller than eggs because the egg is where the zygote is gonna get its nourishment from, so it's actually bigger. All right, and then your last word is somatic cells. So these are all the other cells of your body. Okay, so every single cell in your body besides sperm if you're a male and eggs if you're a female. So again, soma means body. And these cells are diploid. They have a full set of chromosomes. I know there's another vocab word there, but we're going to wait till tomorrow to learn that one. When we start talking about dominant and recessive. All right. I want to show you a little bit about your homework. We're going to give you the rest of the hour to work on. Most of you probably will finish this in just a few minutes. So let me